Okay, so again, we're going to start with the attribution. I think Zach may have mentioned this in a tweet earlier, but I'm going to pull up the most recent verification week. So these are forecasts, 16 to 20-day forecasts up here that were issued on October 29th and verified November 13th to November 17th. So we just got in this verification. And, the main takeaway that I see here, or at least one of the takeaways, is the verification was 123 HDDs. And here's the forecast distribution below that, right? So the coldest forecast in our contest was 102 from the CFS, and that ranged all the way down to 75. And so this is now what, the third week in a row? I think it's the third week in a row, at least, where we've most of the forecasts, if not all the forecasts in our distribution here, underestimated. And I think this was actually the biggest one. I think this was the biggest underestimation. I'll skip to, we can look at last week real quick. I'm just going to go backwards. Hopefully, sometimes there's a little bit of a lag here. There we go. Okay, so last week you can see the verification was 102 HDDs, and Paul, it looks like Professor Roundy there missed it by just about 10. But again, the entire distribution too warm. And just going back to this week, the nearest forecast was about 20 HDDs too warm. So, here we are 3 weeks in a row, underestimating the forecast. And the other, I think, interesting, important takeaway here is the ECMWF. So the ECMWF showed 83 HDDs for this forecast, obviously way too low, but that's been the story so far this heating season. So I'm going to click up here on heating season, and I'm going to sort this highest to lowest, I guess. And you can see the forecast counts here in the third, or I guess it's fourth column. So Matt Rogers, for example, has one forecast, but he made a count. But look at the ECMWF, right? And so this is another area where, Mike, in a second here, I'd love you to chime in on, because this is not something I'm used to seeing. And whenever I see something like this, honestly, my first thought is maybe there's something we're doing wrong with our performance metrics, because, it's not too often I see the ECMWF below the CFS. In terms of forecast skill. But this is something that we noticed this summer, and in particular during pattern shifts, where I don't have the chart right now, but there was a really nice chart that one of our other students created that showed during the pattern transitions, the ECMWF was really, really poor. And then obviously, we've seen so far this heating season, it has not been a good story. So, maybe I'll just stop there now and allow others to chime in. Mike, you're welcome to chime in here in terms of thoughts as to what happened during this forecast window, why we think the forecast underestimated the cold. And I guess importantly here, to get out of sort of the academic, I mean, we do want to look back, but is there something here where we can learn for next time, whether it's literally this week, or whether it's next year, but something that we learned that we maybe adjust, we, look at this kind of situation differently and say, yeah, I would go colder. And I know this is less sexy to give this answer, but is it one of those situations where you look at this and say, you know what, honestly, if I had to do the whole thing over again, I'd probably still, make a forecast of 90 HDDs. So with that, I'll open it up.
So, hey, Dave. It's pretty striking that the ECM did perform so poorly there with the low HDDs. Just a quick clarification. This is the heating season tab we're looking at?
Yes. So we're looking at gas-weighted HDDs.
Okay.
Yeah.
Okay. So looking at that ECMWF week 3 forecast initialized on October 28th, the model was predicting above average temperatures in the western U.S., colder than average in the eastern U.S., but it seemed that it was nowhere close on the amplitude of cold, right? So it definitely undershot the HDD number there. Unfortunately, so I feel pretty bad right now. I was not on the subseasonal desk for the last 3 weeks. So my head was not really paying attention to the models at this point, just because I was working on other things at work. So I am not ready to comment on specifically why the model underperformed. I know that there was a fairly robust shift in the intraseasonal state in the tropics, though, just kind of speeding up over the last day or so, where we observed what was a prolonged coupling to the Indian Ocean dipole. Essentially, we saw an eastward shift from that, where we saw a strong Kelvin wave / MJO. You could call it as a fast MJO or a slow Kelvin wave. The signal kind of lived on both of those bands, those spectral bands there. But it seems like when that shift in the intraseasonal state happened, where we saw the decoupling from the Indian Ocean dipole take place, that's where this significant colder pattern took place. And it seemed to be timed. So like the cold pattern was what, the 11th to the 17th of the last week here?
That's right. And while you're talking, I'll pull up a map here. Go ahead.
Yeah, it seemed that this coldest period was when this convexly coupled Kelvin wave or fast MJO was passing the same longitude as the Western Hemisphere. So to comment on why it was so cold, that's something that I'm not sure why the model missed it. I wasn't looking too deeply into that with regards to specific attribution of why, unfortunately. But looking at the pattern, it was this past week was like a wave number 4 pattern where we saw a pretty high amplitude ridge from the western North America up through Alaska and into Siberia there, and that essentially created an environment for cross-polar flow. It'd be interesting to see the 500 height anomaly pattern from the ECMWF. Let me see if I can dig that up pretty quickly. What are we looking at here? This is actuals, right?
Yeah, that's right. And I might be able to at least pull up.
Let's see if I can find it. So yeah, we got cut off in 28th.
Like this is not the 500, but this is the temperature pattern from during that period. And
so it seems like it did okay with the warm west idea, but it completely undershot the cold in the east.
Right, exactly.
I'm looking into some archived reports from our other forecaster to see if there's a 500 height anomaly forecast on there. So
okay,
that might help. Nope, I don't have it. It's unfortunate. Wow.
And I was going to say, you brought up an interesting point. I just want to expand on that a little bit. One of the things that have come up as a topic over the last several weeks is the cold pool over Canada. And there's been a question, a debate, I guess, as to this map we're looking at here in particular is the last 7 days. So a lot of it has been now dislodged into the eastern United States. But there's been a question about how well the models resolve the spatial and intensity of the cold in Canada and nearby areas, and if it doesn't initialize it well, or if it reduces it too quickly, that did that play some part of the role in underestimating the cold that eventually was delivered 2-3 weeks later. I don't know if you have any thoughts on that. Feel free to poo-poo it.
Yeah, no, I mean, that's a good question for, I guess, surface land feedbacks, right? If there's that colder pressure, like high pressure, how do the models resolve that? To my best of knowledge, I haven't typically seen any resources to suggest that models are missing that interaction. Typically in these big busts like this, it's usually because the models are missing the actual pattern. And I actually was able to dig up the week 3 forecast 500 height anomaly pattern forecast from the ECMWF. I can send you an email if you want.
Would you like to share your screen?
Sure, I can share it quick.
Over to you.
Let me know if you see the screen.
Got it.
Okay, yeah. So here was the 500 overhead anomaly forecast from October 28th. I believe that's the time we're just referring to.
That's perfect.
Yeah, so you can see how the model was pretty much indicating a robust vortex or upper level disturbance across eastern Canada, the Hudson Bay, into the southern tip of Greenland. This is kind of like a positive NAO, if you want to call it that, with essentially shifted west a bit. But out on the Pacific side, you often, for U.S. forecasting, you always want to look upstream because it's more important for the Pacific. And you can see that there was this upper level disturbance over the northeastern subtropical Pacific. And that's typically a signature that can drive in an extension of the Pacific jet across the U.S. And I suspect that's why we were seeing this subtropical ridge, or this ridge, or above normal height signature start to flex over the Rockies and the plains there. And you can kind of see the above normal heights all the way through the northeast, indicating some kind of a split flow pattern with a cutoff of the southeast. So if we were to look back at that particular verification week, let me see if I have it here. So I'm going to try to bring them up next to each other. Hold on a sec. Unfortunately, there we go. Okay. And then, so we can kind of diagnose where the model went wrong. I mean, it seems like it was a major fail in the model upstream over the Pacific, right? In the sense that this looked to be a bit more intensive of a trough that resulted in a stronger ridge across Western North America. And that really seemed to be the deciding factor there. Though the ridge was there, if you were to do a correlation height anomaly analysis here, it's not bad. But it does seem that these subtle differences, especially as you get up into Western Canada, the amplitude there really, the model just underperformed with the amplitude of the Western ridge, and that resulted in a deeper connection with this trough that then you didn't really see that cutoff pattern, though it wasn't too bad. You can see some weakness in the verification there. And you have a below normal height signature where it was being predicted, but it seemed to have more of a connection with that deeper reservoir of colder air, and that was probably the deciding factor. So just a very subtle difference there in the pattern made a huge difference in the the HDD forecast.
Like, I think that last point's a great point. That's exactly what I was thinking too. In fact, even if we don't need to do this, but if you zoom in on that exact 5-day period, the differences I think between the forecast and verification are even smaller. Yeah. And what strikes me is exactly what you said. And I think this is an important takeaway, that from a forecast error standpoint, from if you were just looking at this in terms of like 500 millbar heights, right, spatial correlation or whatever, I suspect this forecast error was not, again, I'm speculating, right, this is subjective, but I guess that it's within the normal bounds, right, not an unusual kind of error. It wasn't a high error type forecast. Maybe it was right. Better, maybe it was slightly worse, but like you made the point, it's not like the jet stream pattern reversed. It's not like it was forecasting a trough ridge and it verified a ridge trough. We see that again. That's not what happened this time. This reminds me of something Professor Torn at Albany once told me when I asked him. I said, what situations do you think produce the lowest confidence type forecast when you're forecasting temperatures in the United States and you're forecasting, say, for the region of Chicago to New York, i.e., a gas demand area? And he said when there's situations where there's a strong delineation of temperatures near that area. And to me, that's probably what happened. Again, we talked about that there was this incredible source region of cold, whether it was just north of the border, whether it was just along the border, a little west, east. But if that shifted a little bit further south, and it looks like it did, all of a sudden you were able to create a much greater HDD kind of outcome for the eastern United States. And then it's how do you, even if, okay, so we say, okay, that's right. How do you adjust for that, right? How do you account for that in a situation where, you may, from a jet stream pattern, you may think the models even have a good handle on it, but you still know that even if the models do reasonably well at the upper levels, that there could still be dramatic errors at the surface where it counts.
Yeah, I've envisioned some sort of some project where maybe you do some machine learning or deep learning on the hindcast forecasts to be able to help with this problem. But it's that's I'm not sure what that would result in that study. But I assume if this is a common problem where you get this cold pool reservoir of air and the amplitudes of the anomalies are quite weak, maybe you expect these amplitudes to be stronger, and then that could result in this pocket of cold coming down a little bit further. I don't know.
Yeah, I have some comments, if you don't mind, Dave, on this situation. First, Mike, nice to hear from you. Nice to talk with you. I think you can take your machine learning comments and stick them where the sun don't shine, though. I don't want to hear that from my PhD subseasonal expert. I think machine learning is a four-letter word where I come from. I think we should be attacking all this stuff from dynamical principles and keep the numerical methods and machine learning folks, out with Google and Amazon and those places. I don't think they belong in meteorology. Anyway, that's a bourbon-fueled discussion we can have down the road.
Sure.
Welcome to the Stone Ages.
The Stone Age. I firmly disagree with that idea.
I knew you would.
So this particular situation, I think, was ripe for a not necessarily a gut call, but a dynamically driven, hey, there's higher risk to the cold side here. And it starts with wavelength and phase. That Euro weekly or week 3 forecast there already has a wavelength that we have not seen anything close to in this cold season. There's been no substantial separation between ridge and trough axes with that kind of pattern, and I don't think there was any reason to expect that. So right out of the gate, I think you could shorten the wavelengths. And the other thing that really jumped out at me, this came at the end of a 10+ day stretch of negative WPO, negative EPO combination, which I know we've mentioned that Canada got loaded up with cold. All you needed was some kind of impetus to inject a little bit more amplitude into the system, and then you had what amounted to a teleconnection jackpot for cold with negative Pacific-driven, high latitude Pacific-driven index values. And while I hate the PNA for predictive value, it's a nice lag zero character describer of the pattern. If you could somehow spike the PNA more positive, that was the missing link. That was the connection between a mid-latitude ridge segment and higher latitude ridge segments that were already there, way stronger than the Euro Weekly suggested up into Northwest Canada. That happened to coincide with a very nice eastward propagating mode of convection that Mike already mentioned. But more importantly, I think for the first time this cold season, that convective mode connected more directly to the mid-latitude jet structure, and it had a really nice breakout GWO phase space circuit that went through the top side of GWO phase space. And when you connect those composites up, you automatically start looking for more full latitude ridging up the west coast of North America. The last piece, there was a little tropical cyclone interaction here in the West Pac. Now, I'm not, we've talked about this before in here. Not every recurving tropical cyclone in the western half of the Pacific is a cold catalyst. And in particular, this cold season, the primary result has not necessarily been to extend the Pacific jet and do regime change kind of things. It's been more along the lines of inject temporary bouts of increased amplitude. And I think that's key here. If you just amplify that week 3 pattern from the Euro weeklies, even with the phase shift error, you're still going to get substantially colder in the eastern part of the nation. So the combination of those 3 things tilted the deck towards the colder side in the analysis that I remember through this period.
All right, thanks, Jason. Although we can stay on this topic for a while, I suggest we kind of segue now to the forecast. Okay. Let's see here. I'll share my screen again. Okay, and then I'm going to turn it over to Zach here in a second. So again, Zach's going to follow that script. He's going to give a briefing to Michael, but Michael Ventrice. But everyone else here can jump in, right? You all work with Mike. You all work for Mike Ventrice here. Everyone else on the line. So maybe you haven't been making money lately. No, you don't have to go there. But anyway, so I'm going to turn over to Zach to do his briefing. But again, jump in. You're the clients, and feel free to jump in wherever you see fit.
All right. Hey, Mike. So my forecast for the period of December 4th to December 8th is 131.2 HDDs with a spread of 24.7 HDDs. It's coming in slightly colder than the 30-year benchmark. So my forecast process changed a little bit from last week, but still kind of the overall trend of keeping the 30-year as my main forecast metric. I put a 60% weighting on the 30-year, 20% on the trend, 10% on the EC, and 10% on the CFS. Basically, what I believe the pattern is going to be some sort of, I believe it's a trough ridge pattern, but there's I have a lot of uncertainty about the magnitude based on the fact that the models have been struggling getting the magnitude of the troughs and ridges correct. So I have a lot of variability, or a lot of questions about the pattern itself, because I found a lot of variability in some of the outputs that I've looked at. The CPC is actually showing a ridge trough pattern, whereas the CFS and the EC are showing trough ridge patterns. But the CFS was a lot stronger than the EC was. And then I didn't see any real strong teleconnection pattern, and particularly the NAO, PNA, and AO were all showing weak to potentially neutral patterns there. So yeah, the only real variability and risk I see in this forecast is the potential that the models may not be getting the pattern correct, and that could lead to some forecast busts.
So I had a quick question, Zach. Where do you, if you were to be able to give me a couple of scenarios where, you give me the scenario where you believe it's going to happen, but then give me an alternate scenario where the risk lies, what would you think that alternate scenario would be?
Well, based on some of what I've seen, I believe the scenario is going to be more of a trough ridge pattern, but it's perfectly possible based on what I saw from the CPC that it could be the complete opposite, where we have the trough in the east, and that could lead to some very below normal, so a lot of below normal colds on the eastern half of the U.S. Okay, so when you said trough ridge, you're essentially going from west to east or on the U.S.? Yes. Yeah. Sorry, I meant to clarify that, but my apologies, I didn't do that. No worries. So okay, so you're thinking there's going to be a trough in the west and a ridge in the east. Is that correct? Yeah. Okay. And have you looked at any of the models in the medium range to kind of see where the pattern might be heading towards in that early week 3 time frame, or is this kind of just looking at like statistical analyses or the data just given here? No, I basically just looked straight at the data. I didn't look at how the models were progressing towards that week 3 period. Okay. Yeah, that's okay. So it's so we're looking at, what is this, a CFS here, Dave, or ECM? Oh, ECM. Okay. Yep. Gotcha. Okay. Now I'm interested. If you were to take a look at the end of the 11-15 day period from the ECM, how if that would change your thoughts at all or not.
Let's pull it up.
I don't know if we can break it down into those, yeah, oh, great, excellent.
Here's the near the end, Zach.
So the forecast begins on what, the 2nd of December? So this is the 3rd, this is the 2nd of December, we could say. So does this forecast map change your opinion at all? Or do you think that this could be it just seems that it does show like a below average anomaly in the west, but it seems pretty strong with that trough in the northeast. So
yeah, no, that definitely adds a little bit of uncertainty, even more uncertainty than I already had. I definitely need to factor in how the models progress and what's going on before that 3-week period starts, because that this definitely changes.
Did you show the northern hemispheric projection of that the same time step? All right, so my question, Zach, would be, what's your biggest supporting factor pattern-wise for cold, and what's your biggest supporting factor-wise for warm, to lead the witness a little bit?
Well, like I said, originally I had the trough in the west and the ridge in the east. So those are
That's the result. What's the biggest driving factor that would put the ridge in the west and the trough in the east? And then conversely, what's the biggest driving factor that would not do that?
Are you talking in terms of something that the model does, or just like what the pattern actually is? Any sort of?
Yeah, from a pattern evolution perspective, and you could comment on the end of the Euro ensemble here, or whatever forecast item that drove your 16 to 20.
I guess looking here, I would the strong ridging pattern across the south of Alaska would mean the main thing that would sort of progress over the U.S.
Mm-hmm. And then on the flip side, got a pretty good argument here between the Pacific side and northern latitude Atlantic side. I guess what I'm kind of getting at is the Pacific pattern kind of suggests zonal to negative PNA risk and not cold. And the northern Atlantic side says, I'm going to try and overwhelm this with a more substantial negative NAO projection. And I guess my concern would be, what are your thoughts on, Pacific side forcing versus Atlantic side forcing in early December with a weak INSO background?
Not quite sure. I definitely haven't factored this kind of analysis into my forecast before, so I don't want to give you any sort of answer just winging it.
Understood, and that kind of makes normal as an interesting compromise in that setup.
Yeah, in a situation like that too, if you don't know, you can always tell the client you'll look into that and call them back.
Okay.
Maybe hey, let me get back to you on that. We're going to dig into that a little bit.
Okay.
Any other questions for Zach?
Hey, Dave. Yeah, I do. Would you mind putting back up the screen that's the distribution of the forecast?
Yeah. All right.
And can you sort here by highest to lowest?
Yeah.
Thank you. So, well, actually, we got a couple of market participants. So I'm not plugged into the market. I have no idea what the market's thinking. So this question might go out to the other guys if they choose to answer it, and they may not choose to answer it, which would be fine. But what would be the biggest surprise to the market where you would expect the largest sort of dislocation at this point? It looks like, most of the forecasts here are, on or below the 15-year moving average. Not a huge distribution here, it looks like. What's the mark? What would deviate from the market expectations in a big way?
I think 110 or under.
Okay, so then
warmer than normal.
Gotcha. So then the question to the forecaster here, Zach, I think, what are the odds that we're below the 10-year normal? So that's the lowest of the distribution we see on screen here. What are the odds we come in below that?
Based on what I've seen, if especially with the pattern that I was predicting with more so of a ridge in the east, I could see potentially warmer than normal temperatures on the East Coast. So I'd give this probably maybe like a 15% chance that it's warmer than the 10-year.
So 15, is that what you said, 1.5? And then what would be the odds that we come in higher than 137?
You're talking about the 15-year moving average?
Yep.
I'd say a little bit less, probably around between like 5 and 10%. I definitely think there was a little bit, based on the pattern I projected, a little bit more warm risk than cold risk.
Gotcha. Okay, so you would say there's probably a 2 to 3 times, if forecast goes wrong, there's a 2 to 3x that it's likely to go significantly warmer versus significantly colder.
Yeah.
Got it. Thanks.
Okay. Hey, just for the sake of time today, Mike, why don't we just do a short one? Just because, or I'm sorry, Mike Garoon. Just because I want to give Mike Ventrice some time here before we hit the hour. Actually, Mike Garoon, if you don't mind, Ventrice, if you don't mind, why don't we let you go here second? Because I want to make sure you get some time in here, and then we'll let Michael Garoon finish up for us. Would that be okay?
Sure. So I did not create a forecast today in the sense of an HDD forecast, but we did just issue our week 3 outlook to our clients this morning that I worked on. So, and I apologize, there's a fire truck coming down my street, so you'll hear some horns in a second.
And Mike, you can share your screen if you like.
Okay, there we go. So this was my week 3 map from today. And I struggled today in this forecast for the week 3 time frame with the Pacific versus the Atlantic battle that's ongoing. The models are showing that ridge developing south of the Aleutian, so that there is a signature there that we should start to see some of the pattern shift over Western Canada, and you start to see some cold air develop up there. But with the North Atlantic side, the coin, it does look like there's going to be some Greenland blocking, or west of Greenland, maybe a west shifted negative NAO type pattern. And that in those types of environments, you typically see the cold air scraping across the northeastern tier there, and we get more of these changeable conditions across the southeastern 2/3 of the nation. So to convert this into an HDD forecast, I would suspect it's above the standard 30, but I'm not entirely sure. We don't have an algorithm yet that computes this, these departures from normal to an HDD number. But I would suspect, since the Northeast, much of PJM West and your New England and your New York markets are above normal with seasonal temperatures in the southeast, I would suspect this is just above the 30-year, but I can't confirm that. So the issue, the reason for the forecast, and we talked about the Pacific versus the Atlantic. I always typically look at this problem for the upcoming 3 to 5 weeks as like a layered cake. I want to understand what's going on at the base state of the tropics. I want to understand what's going on at the intraseasonal state in the tropics. I want to understand what's going on in the extratropics, and I want to understand if there's any stratospheric tropospheric interactions that are going on. So a quick and easy way that I look at the tropics at the base state is through this atmospheric ENSO index that I've created, where essentially it's measuring the atmospheric circulation cells over the tropical Pacific at lower frequencies by applying a low pass filter on a velocity potential at 200 millibar height, 200 millibar anomaly. And if I were to look at just it's hard to see here, maybe I can zoom in. If I were to just look at, this is like a week 3-6 aggregate. This is looking at maybe the January timeframe, and this is the February timeframe. If you look at the progression in here, it does show more of this like El Nino type pattern with the trough of the Aleutians, ridge over the North America. That's like a classic El Nino that kind of evolves into more of a negative NAO driver. And this is temperature anomalies for those patterns. The base state in the tropics, at least according to this index and looking at similar states, supports like above normal temperatures, right? The problem is that index is very simple, and it's boiled down to just looking at the Pacific. It doesn't look at the global pattern at lower frequencies, and that's shown here by this low frequency filtered velocity potential global map. And we're actually looking out 15 days from the ECMWF ensemble. So we're looking at essentially, in order to make these maps, I do a low path, or I do a running 120-day filter. So we're looking at like 105 days of observations, or 95 days of observations, and 15 days of forecast, or around there, 100 days, et cetera. So this is mainly observations. That's the whole point. It's mainly observations. I am using a 15-day forecast, but I want to focus on this actual pattern here. And this is a wave number 2 pattern at lower frequencies, right? We have the negative anomalies represent essentially divergent air aloft, or you can think of it as rising air. These are your tropical force zones at lower frequencies. You have that El Nino signature there, but the stronger signature is this African Western Indian Ocean signal, and that's associated with your Indian Ocean dipole event, which you brought up earlier, Dave. And if we were to look at, I didn't include it in this analysis, but if we were looking at the Indian Ocean dipole, I think it's like it was around 2 Celsius above normal. I think it dropped down to like 1.8 or 1.6, but it's still it was a top 3 event in the amplitude of the Indian Ocean dipole. And what this is doing here is it's measuring the atmospheric coupling response. So you're seeing this rising air over Africa and the Western Indian Ocean, and subsidence over the Eastern Indian Ocean and through Australia. There's a nice signature why, if anyone asks you why Australia was dry, it's being dominated by an IOD signal here. And to try to convert this into what it means physically is difficult unless you have, an algorithm that is able to identify these forcing regimes in history. And luckily I do. I'm able to kind of go back based off of that forcing regime at lower frequencies, which is I'm finding at 57 East. What in history has that meant for the U.S.? And it's a warm signal for the U.S. And this is looking at a December aggregate essentially, but you can see here above normal temperatures across the eastern 2/3 of the nation. So the IOD pattern here favors for warmth, at least according to this historical analog set. Looking into the intraseasonal state, moving on to the MJO, dashed contours represent the kinetically active phase of the MJO, and this is what we were talking about during the coldest pattern across the U.S. where models missed it. There was this eastward propagation that essentially we had this constructive interference with the IOD. Then this eastward propagation happened, and we saw a destructive interference with the IOD. And that's at that time is right when we saw the coldest temperatures in the U.S. And now we're going back into this constructive IOD phase. So if you were to look back into this historical period where we had the MJO ringing the IOD bell, we saw pretty robust blocking over Greenland. You had that nice negative NAO pattern across the Europe side of the pond, but in the U.S. we had a ridge essentially in the eastern U.S. connecting to that ridge over Greenland, and that was dominated by the Pacific pattern, right? We had this ridge over the Aleutians, a trough in the west, and a ridge in the east. So similar to what I think Zach was forecasting, this was what we just observed when the MJO was constructively interfering with that IOD pattern. Now there is some indications in the models, however, at the end of the 15-day period. This is the ECMWF 360 forecast. You don't really see that European side signature, that NAO type pattern. If you look at this pattern here, you see the above average heights west of Greenland, and that's where we're seeing this below normal average type of pattern, that west-based negative NAO. So this looks like more of an impact for the U.S. side, and that's where I'm struggling, right? Do we get this Pacific pattern that forces the cold air in the west, or is it going to? It's battling this ridge that's developing west of Greenland, and that's forcing below normal heights. So that's where I was struggling with the forecast. I don't want to get too much more in depth, but shifting now into that stratosphere-tropospheric interaction, there is one main difference now compared to that September-October period to where we are now, and that's the intensity of the stratospheric polar vortex, right? Back in September and October, we had a very strong vortex spinning up, or at least anomalously strong vortex spinning up over the stratosphere. And if you were to look at the forecast now in the next 15 days, we're seeing some significant weakening of the stratospheric polar vortex, and there is some a warming event predicted across North America, but also into the North Pole region. And you can actually see at 10 millibars, there's a stratospheric ridge setting up, pretty much stretching across the northern, pretty much across Canada. Now, this is a minor event. If you were to look at, if you were to talk to a stratosphere expert, they would say this is nothing, this is not important. I'm trying to do more research on these types of events, understanding where the warming is located, because it can happen anywhere. You can do an EOF analysis at 10 millibars and look at the temperature anomalies and find the loading patterns for where warming is. And I'm able to do that and essentially, identify all warming cases over North America to see if there's any meaningful information. I just wanted to focus. This is a StratObserve diagram of the stratospheric polar vortex, and I loved looking at these. That kind of opened my eyes when looking at strat warming events, and you can clearly see there's a nice tropospheric forcing on the stratospheric vortex, and you can kind of see this tail of higher PV kind of extending from the reservoir. As you look at the end of the GFS forecast, I think this was yesterday's run, the vortex doesn't look that healthy anymore, but it's still there. It's not like we're going to see a split at all. I went back into my research to see if I could identify stratospheric vortex warming events. Stratosphere warming events over the North America using an EOF analysis, and I was able to find an EOF that matched those North American warming events in December and January. And 10 days prior to the event, we get this pretty strong vortex over the North Pacific. And we're seeing a cycle. This is the 500 more head anomaly pattern now for both cases here. This is the composite. This is looking at some model data to see if there's any similarities at all. And you kind of see this Aleutian cyclone, and you get this ring of above normal heights, similar to the composite. Looking at around the time of warming in the stratosphere over North America, you get essentially these two lobes in the composites of negative G potential height perturbations. So essentially a vortex over Siberia and one over Western North America. And we kind of see a similar pattern. This is pretty new to me, so I'm just kind of sharing results on the fly with you guys. And this is to kind of understand from the stratosphere connection if there's anything there. And then looking at essentially 7 days following the North American event, you get this ridge over the Aleutians and then like a trough over Western North America and a ridge in the southeast here. So that's that negative PNA type pattern. So there's an indication here that maybe in the next 2 weeks or so we get some sort of negative PNA flex. And then I just ran these composites out 14 days and 21 days later in time, and we get more of this NAO type blocking signature with this kind of below normal height signature across the Northeast. And this kind of looks like the ECM at the end of the forecast. And I thought it was interesting, so that's why I put it in here. I did recommend to the clients, like, hey, listen, this is new research. I'm not sure if this is exactly, if there's any truth in here. This could be all smoking mirrors, but it was just an independent study that I performed and then trying to use it as like, hey, maybe there's a chance here the West-based negative NAO has some ties to the North American warming. I don't know. It sounds crazy to me because I'm not a stratosphere expert, but it's things that I'm trying to understand while writing the report, looking for any type of driver and connection there. One last thing that I want to talk about, and I'll zoom out here. I've become a fan of looking at 500 millibar height anomalies in a Hofmüller format, where we're looking at an average over the extratropics, 50 north, 80 north. We're showing positive height anomalies indicated by the red shading and negative height anomalies indicated by the blue shading. And time is going down on the y-axis and longitude is on the x-axis. there's a mini map here underneath if you want to take a look at where you are in the world. And I've noticed since the late October timeframe, we started to get this westward propagation or progression of both negative and height perturbations with time. And it's acting at an oscillation of about 30 days. And this is consistent with the Brandstater-Kushner-Rossby wave that travels in the extratropics. And I'm, again, not an expert on these waves. I just started to look at them more frequently after doing, 5+ years of subseasonal forecasting, because it seems like there's predictability in these waves of predicting when we should see either North Pacific ridge flexes or North Atlantic ridge flexes, right? So if we were to look back at that early November timeframe, it does seem that there was this positive height perturbation across the North Pacific, which potentially it was driving some of that colder air across the eastern markets. And then we've seen a general westward shift to over Western Eurasia. And then the forecast calls for this to continue across the North Atlantic. So this is where we get that negative NAO flex. And I suspect with time, we'll see the ridge, that positive height perturbation continue across the North Pacific in that late week 3 or week 4 timeframe. So this is a forecast here for me, at least in week 3, that I think there's going to be this West NAO type forecast pattern, which is why the ECMWF ensembles is showing it. But I don't think it's going to be a permanent feature, right? So so I think that the North Pacific Ridge idea and getting to where Zach was forecasting, I think there's a chance of that to happen in the week 3 timeframe, but I think it's going to be either late in week 3 or in week 4. So that's why I had this struggle in this week 3 timeframe, where I'll bring my map back up one more time, where I think this cold pattern in Western Canada is going to amplify as the week 3 time frame moves forward. So getting later in the week, I feel better about this colder pattern, but I also think this NAO type pattern blocking in western Greenland into the Hudson Bay will allow for at least some colder patterns and stormy conditions across the eastern, northeastern US. And then I think as the week progresses, we'll start to see the North Pacific Ridge flex more. That keeps that locks in that cold air across Western Canada. And I do think that the Southeast Ridge is going to start to flex up here. But that's essentially why I drove my forecast here. And it's a complicated beast, but I guess that's the thinking that I had behind the map. It's an evolutionary time frame, which makes things difficult because now we're worried about timing issues. And let's say the North Pacific Ridge doesn't build as I expected to with a higher amplitude at the higher latitudes. Maybe the eastern U.S. is actually colder than what I have forecast here. But if we see the ridge over the North Pacific get stronger later in the week, that week 3 time frame, I think we'll start to see more of the negative PNA evolve, and that shifts your forecast warmer across the southeast and colder across the northwest. Okay, I'm going to stop there.
All right, no, that's great, Mike. And we don't have a lot of time, guys. So if you have questions for Mike, let's just try to keep them concise here, because I also want to give Mike Roon a minute or two. I'll lead off with one very hopefully quick question. Mike, how would you translate this into confidence? So we provide a sigma in ours, and I think the sigma, the 30-year sigma, is about 24 HDDs. Would your forecast sigma be higher than that, lower than that, or about consistent with sort of average confidence?
So I feel like it would be a little bit lower than that, and that ties into this clustering product that we have that we make available for our clients. And the reason why I feel it's a little bit lower is because this top cluster here actually is so the green text here shows the percentage of members in the ECMWF monthly model for initialized on Monday, how many members fall into that cluster. And a 57% cluster, 57% or over half the number of ECMWF monthly members are falling into this cluster category, which I'm able to actually, let me bring up a map here quick. I've been keeping statistics on the frequency of clustering in the ECMWF weekly model. Give me a sec here. I know we're running short on time, so I apologize, but I think it's interesting.
And while you're doing that, I just want to be clear. When you say lower, so you have a tighter distribution, higher.
Yes.
Okay.
Yes, I have higher confidence in that forecast. If we look, that week 3 time frame had 57% members, and this is the distribution over 288 individual forecasts from the ECMWF weekly model of the PDF of percent members on the x-axis for week 3. And this is the CONUS. So 57% is a tail distribution here. So this is a rare event in the model where there's such a high clustering. Now, you obviously have to worry about under-dispersitivity, but I feel at least at this point that I would suggest higher than normal confidence based off of this clustering.
Got it. Okay, thank you. We have time for 1 or 2 more questions for Michael. Right. Thanks. Well, okay. So Mike Garoon, we're going to switch it over to you. And this is going to be a great case here. You've got your customer here, your client, Michael Ventrice, only has 2 minutes. So you got to give him the big scoop here in 2 minutes. Otherwise, he's going to hang up on you. So, Mike, do you want the screen?
No, that's okay.
Okay. All right. I'll share my screen. I'll put up the forecast. Over to you.
All right, so hello, Michael. My forecast for this week is for 126.9 HDDs. This is slightly warmer than the 30-year, coming in at 129.6. My sigma value is 30, which is, I believe, a 1 1/4 sigma higher than, a quarter sigma higher than the normal spread. The reason for this I will get to in a minute. So my forecast basically this week, one minor change. I've switched over from the 10-year to the 30-year since the 30-year tends to do better in the winter. Most of my forecast is based off of teleconnections and a little bit of the CPC. The main driver of my forecast this week was I didn't really see a strong signal from either the NAO or the PNA. So I kind of took most of it from a negative AO. So I'm kind of expecting some transient cold shots with that negative AO. And, you know, so not really a trough or a ridge anywhere, but just kind of things progressing and flowing. And so you get cold in the west and then warm in the east, and then you'll get warm in the west, cold in the east. As for some risks, if the AO doesn't materialize as negative as I think it's going to, that's a large risk. Another big risk is the CPC, as Zach alluded to earlier, shows a strong ridge in the east, or at least strong warm anomalies in the west, I should say. So that's another risk to the forecast. If we do get that warmth in the west, then there'll probably be a little bit more cold in the east as a result, and that's a larger population center, places like New York and Chicago. As for the odds of it going below or above the forecast range, I would say about a 15% chance of it going above the forecast range, and only about a 7 or 8% chance of it going colder than the forecast range.
Thanks, Michael. I had a question. I recall that the AO correlation with CONUS HDD is probably one of the least correlated teleconnections compared to some of the other teleconnection indices. And with some of the the ECM week 3 model showing essentially a below normal heights across the North Pole, I'm just wondering on if you're worried at all that the AO is could be a opposite to what you suggested, and also if the correlations are quite weak with CONUS CDDs or HDDs, I'm sorry, in December, what else should I be looking for?
Yeah, there's definitely a concern there, especially since I also look at the verifications of the last 14 days
Mhm.
of the 14-day forecast of these teleconnections, and it has consistently come in a little bit over, a little bit more positive, I believe, um, than normal, at least recently, as you can see. So
Mm.
there is a concern there. The other thing I would look at is the PNA does have a chance. It's currently forecasted to be positive. At least I believe these are the GFS ensembles. So that's another concern, since I've heard that most of the expectations is for a negative PNA. So that could reinforce actually reinforce my forecast if it does go positive.
Mhm.
But as for so if does that answer your question, or?
Yeah, no. So actually looking for the PNA potentially to see how the model trends with time.
Yes.
And if we start to see a positive trend, you feel better about the colder in the east.
Yeah.
Okay. Thank you.
All right, great guys. I know we're out of time, Mike. I don't want to keep you any longer, but I want to thank everyone: Mike Ventrice, Jason Lynn, Steve Bennett. Thank you for sharing your time with us here today, and hopefully we can have you guys back soon. And Mike Ventrice, we'll certainly reach out to you here, maybe in another month or so, and see if we can get you back on the ticket.
Okay. Thanks for having me, Dave.
All right, thanks, guys.
Thanks, Dave. Nice discussion, Mike. Catch you later.
Bye, guys.
Guys, nice to chat with you guys. Bye.